The Robotics Developer Masterclass is a bootcamp designed to help you master robotics development from zero to advanced and get you fully prepared to work in any robotics company. From the basics of programming Python and C++ to advanced robotics programming techniques like ROS, robot reception, and autonomous robot navigation. Build a robot simulation from zero, make a robotic arm perform pick-and-place tasks, develop a web app that interacts with a robot, and more. This program will equip you with 99% of the skills required for any robotics development job. Every day, you will learn each concept by practicing with simulated and real robots. Combine our online IDE with remote real robot labs that will drop you into real-world scenarios and make you learn by doing it in real Rob Dev environments. You'll have a dedicated mentor to guide your progress, answer all your questions, and ensure your success. The Robotics Developer Masterclass will also provide you with a one-month internship in a leading robotics company. You'll learn from industry practitioners and enhance your knowledge. Enroll now to kickstart your robotics career with the Construct.
Hello there, ROS developers, and welcome to a new OpenClass. We are today in OpenClass number 135, and today we are going to see how to set up an online ROS class in just 1 minute or less. In just very few steps, you are going to see all this in a moment. So get ready, because today I'm going to be sharing some licenses for the Academy with you guys, so that we can all together build a ROS online class. So let's not lose any more time, and let's go for it. So I'm going to start right now switching to my computer screen, but before that I want to make sure that everything is fine, sound is fine, image is fine. Can you maybe confirm here in the chat that everything is working properly? I can see there we have here Chuya, Miguel is saying that everything is okay. All right, so let me switch right now to my computer screen. All right, there we go. Okay, so for today's open class, we are not going to work with a rosject as usual. So usually here in the live class section, we have this rosject that you have to copy to your workspace and so on. Today we are not going to work with a rosject, but we are going to be working with a course directly. All right, so that's why there is no rosject available for today's live class. Don't worry, it's normal. All right, then let me check here. So Chuya, Miguel say at the intro there was echo. Okay, I'm going to take notes about that. So it looks like in the intro video there was some echo. All right, then so let's start with the open class. So today we are going to I'm going to start by setting up and showing you how to set up very easily in just a few steps, how to set up a ROS online class for thousands, hundreds of students from anywhere in the world. Okay, in about a minute. So it's going to be super easy. You're going to see it in a moment. I'm going to show you all the steps, how to do this, how to build a ROS online class. And then after that, once we have set up all the licenses, you have access to the Academy and so on, we are going to go to one specific course, one of the latest courses that we have added, which is working with an RV car from Robotnik, an autonomous car. And we are going to see a couple of simple examples using this robot. And then later on, of course, if you want, you can continue doing the course by your own, or you can change to another course and check other courses, because you are going to have this license for 24 hours. All right? Then let me start setting all up, and then meanwhile I am doing so, I will be explaining to you everything more in detail. So let's go for it. Then All right, so right now, the first thing that you should do is to, of course, log in here to your Deconstruct account. I am already logged in mine, and in my case, I have a special license because I have set up my account in order to have 50 licenses. Okay, then of course I have multiple licenses because I'm going to be sharing right now these licenses with you. With all the people who is here in the OpenClass, in the chat, you are going to be able to get one of these licenses. Then, since I have multiple licenses, 50 in this case, I have one special option in my Deconstruct page, which you are not going to have, okay? This option is only available for people who gets multiple licenses, okay? So this option, you can find it here in the left menu, in the team management area. It's this members area, okay? This area here is only available for people who has multiple licenses, like it is my case. Then if I click here, this is going to take me to this page, okay? This is the page where I'm going to be able to manage my team, my students. This can be a team in an enterprise. It can be a class with the students, whatever. At the end, it's to manage multiple members. Then this is the page that I'm going to use in order to manage all these licenses and all the people who is getting my licenses. All right. So as you can see, first of all, here I have 50 licenses and only one so far is being used, which is mine, of course. So automatically, one of the licenses that I have assigned to my account is assigned to me, which is this one. Then there are 49 remaining. So right now, as you can see, there are 0 students online. Then in order to share licenses with other people, the only thing I need to do is to click here in the Add Member button. Okay, so I'm going to do this right now. I'm going to click here in the Add Member button. And this, as you can see, what does is to generate this link here. It automatically generates this link. And then with this link, anybody who clicks in this link is going to be able to get one of these licenses. All right, as easy as this. So I'm going to share this link with you right now. So let me copy it here, and then let me go back here to the workshops page, to the live class page. I'm going to move this, and then I'm going to share this license here in the chat. Okay, so now you can click on this license. You can copy it from here and paste it to your URL if you want. And then this is going to automatically assign one of these licenses to you. Okay, so please go ahead, get this link here, paste it to your URL, this link I have just shared here, and this is going to automatically assign one of these licenses to you. Okay? So while you are getting these licenses, by the way, I'm going to be able to see here which licenses are getting assigned. As you can see, they are already showing here. Maciej Morawski has gotten one license right now. Miguel Ángel Rodriguez also has taken another license. Let me refresh this. So far, only 2. Then, meanwhile, you guys are getting these licenses. I'm going to share some things about this page. So as you can see here with this page, I'm able to see the activity of all the people who has my licenses, when they were added, when it was their last login, the last activity duration. I can also, for instance, here enable exams for some specific courses. Right now I have them deactivated, but in case I want my students or my team members to do a certain exam, I can activate them from here as well. And of course I can see the results of the exams that my students are getting. Also, I can see the results of the quizzes, if they have earned any certificate or not. files. I can also remove one of the licenses. For instance, Miguel, I don't like him very much. So I'm going to remove his license. No, I'm just joking. But I can also remove licenses, etc., etc. We can see some more people here getting licenses. Carmen Delgado. This name, I'm not sure if I'm going to be brave enough to pronounce it properly. Utham Kumar also has gotten another license. So let's refresh this and see if we get any new licenses assigned. Okay, 4 so far. As you can see, so far 5 licenses of 15 have been assigned, which is at 10%. So let me have a quick look here at the chat to see what you guys are saying. Got the license. I had to copy and paste it into my URL bar. Yeah, I see that this link is not directly clickable here from the chat. So the best thing that you can do is to just copy it here from the chat like this and paste it directly to the URL. Or you can paste it directly here or whatever. Okay? So let me remind it one more time in case somebody is late to the live class. Okay, let me remind one last time this process. So basically, what I have done here, Ryan has gotten also a license. So basically, here in the account that I am currently on, I have multiple licenses. I have assigned to myself 50 licenses. Okay, then because I have multiple licenses, I have access to this members area in the construct page, which is this page that you can see right here. Okay, then what I have done is to share these licenses with you so that you can get these licenses for free, of course. Then this is done super easily just by clicking here in the add member option. I can click in this add member option and this generates a URL automatically. Then I have shared this URL with you guys here in the chat so that you can get this URL with you guys. And with this URL, you are going to get one of these 50 licenses assigned to you. Okay? So this license, let me tell you, that is going to be valid until 22 of December, which is tomorrow. Okay, so it's going to last for 24 hours from right now. Okay, it's going to be valid for 24 hours. After that, this license is going to expire. Okay, this is just a demo license, let's say. So we are going to have it active for 24 hours. So during the following 24 hours, you are going to have access to all the courses of our academy. Almost all of them, only the regular courses. You are not going to have access to the enterprise ones, but you are going to have access to most of the courses of our academy. So you can check them, whatever you want to do. All right? Then, yeah, let's have a quick look here and see if any other license have been assigned or not. Looks like not. We have 5 licenses assigned. Let me tell you that I'm going to share also this link later. I'm going to add this link in the description area of the YouTube video because I know that we have many viewers that are going to check the YouTube video. So I'm going to share also this link in the description section of the YouTube video so that the YouTube viewers, hello there YouTube viewers, so that the YouTube viewers can also get a license and try this out, okay? So, yes. All right, so yeah, I think that we are going to start with the course. We had another license assigned here. All right, so let's go for it. Then at this point, let me know, have you been able to get the license properly? Any issues so far? I don't see any comments here in the chat, so probably no issues. So yeah, as I have just said, at this point you have access to most of the courses of the academy. Okay. In this case, for today's open class, we are going to be following one of the latest ones, which is the RB car course. If you click, you can click here in the search bar to find it fast, RB car, and you're going to get this result, which is the Mastering ROS RB car. Okay, so we can come to the details page of this course, then today we are going to start following this course. Okay, this course has been, as I have just said, has been recently in the last weeks published into our academy. This has been a course created in collaboration with the people, our friends of Robotnik, and this course basically teaches how to work with the RB car, autonomous car from Robotnik, which is this super cool car. And then we are going to start following this course, and then, of course, we are not going to have enough time to complete it. But after this open class finishes, you can keep working on the course since you have a license. All right. So let's click here on the start course and let's go for it. Okay. Let me click here on the start course button, and this is going to start the environment of the course. So all of you should, guys, do the same. Open this RB car course. Oh, by the way, let me tell you, because since today we are not working with a rosject as regular, what I suggest you to do is to have on one page opened here the live stream, so that you have access to the chat and everything, and you can also see what I am doing. And then in another tab, as I have my setup here, in another tab, just open the course. Okay? Because if you have only the course opened, you are not going to be able to see the stream, and you are not going to have the chat available. So please do it like this. Have in one tab opened the course, and in the other one the live class. I can see here that Masiesh and Utham Kumar say that no issues. Great. So let's keep going. All right. Then as soon as you launch the course, you are going to get this course page. Let me get a little bit far away from the simulation. And so you are going to have here this super cool simulation of the RB car with this minimalistic city that you can see here, which is looking also super nice. Then we are going to skip this unit 0, okay? So by default, you are going to start here in the unit 0, which is the introduction to the course. So we are going to skip this unit, and we are going to move to unit 1, RB car introduction. Okay, so you can come directly by clicking here in the unit 1, in the unit 1 here option, or you can also click here in the go to the next unit button, which is going to take you to unit 1 also. Okay, so let me click here and go to unit 1, which is titled RB car introduction. Okay, so I want all of you to be here in this section. Of the course, with everything ready. We have here at the left side the notebook, we have here the IDE and the web shells, and also the simulation here with the RB car on it. So yeah, let me know. So far so good. Are you here? Please, the course name is asking Jared. Yeah, the course name is RB car mastering course. You can type here in the search bar RB car, and it's going to display it here for you. Okay, so this one, mastering ROS, RB car. Yeah, so far so good. Have you all reached unit 1 of the course? Are you all here? Masiech says that yes, I am here. Okay, great. Also, Shuhype. Not yet, Jared. Okay. Jared, have you taken one of the licenses or not? Because I don't remember seeing you there in in the members page. Let me see, Jared. Oh yeah, here you are, here you are. Yeah. Okay, so here we can see, for instance, that Ryan Schmalenberg has one certificate, which is Code Foundation for ROS. Congratulations, Ryan, on this certificate. Probably you earned it previously, so it's displaying here for you. Okay, so yeah, Jared also has a license, which was concerning me. Okay, so let's... Thank you. You're welcome, Ryan. Okay, so let's go for it then. Let's start with the course. So what I'm going to do right now is just to follow here the instructions of the notebook, okay? So basically I'm going to be doing step by step this unit, okay? We are going to arrive until where we arrive, where the time limitations allow us to arrive. But basically, what I want you to see here is before we start with the class itself and following the notebook and the course, what I want you to see here is how simple it is for you to set up an online ROS class. Okay, so it's as easy as this. So you only need to have one account with multiple licenses, and then on that point, using this members page and the team management area here, you can very easily assign licenses to multiple students, as many students as licenses you have, by just sharing one link with them, as I have just done here in the chat with you. Okay, so just like this, as simple as this, you can set up a ROS online class from anywhere in the world. Okay, you don't even need to have a specific ROS setup, so you only need access to the internet in order to set up this. Okay? So, yeah, let's go for it. Let me open here again the OpenClass page so that I can see the chat comments. All right. Then, yeah, so basically, as you can see, this simulation is a minimalistic representation of a city. It has most of the elements that you could find in a city, like people around. It has other cars, even. You can find also roads with lane lines. You can find traffic lights, buildings, traffic signals, etc., etc. Okay, so here we have one guy which is about to cross the street. So we have to be careful with him, and yeah. So first thing that we are going to do is to see how to interact here with the traffic lights, which in this simulation we can do this using a service. Yeah, if we type here ROS service list, this is going to show us a list with all the services of the simulation, and one of them is this traffic lights service. Okay, so by calling to this service, as you can see in this command right here, ROS service call traffic light service. By calling to this service, we can change the status of the traffic lights. Okay, however, we are not going to see this directly in the simulation. So let me do this very quickly. So if you execute this command here, as I have just done now, as you can see in the simulation, I cannot see any change in the light, right? So apparently nothing is changing, but this is not really true. So we cannot see it in the simulation, but actually we can see it with the camera of the car. Okay, this is a bug in the simulation, but actually with this simulation we have RVs automatically launched. Okay, so we can visualize RVs by clicking on the graphical tools button, which is this computer-like this screen-like icon that we have here. If you click on this icon here, this is going to open the graphical tools window. Then, as you can see here, we have the RV's visualization of our car, okay? With the robot model, the TFs also are there. And then we have some other visualizations. And here, one of them is this raw image visualization, which right now it's unchecked, so it's not activated, okay? This raw image display here is going to allow us to see what the camera of the car is getting. So let me activate it here. Let me make this. Oh no, sorry, it's not this raw image, but it's the traffic light detection, which is down here. Okay, if you scroll down, you are going to find it here. Traffic light detection. Okay, we have it here, but it's in yellow, so we are not receiving anything. So let me see, let me come back here to see what we are missing. Okay, so let me switch here to the raw image. Okay, there we go. Yeah, here we are. So here, as you can see in this image display, we have many options. So we can come directly to the raw image, okay, which is the front camera of the robot. And then, since we don't have any traffic light around here, I'm going to move a little bit backwards so that I can visualize this traffic light here from my camera, okay? So in order to move the car, we can run this command here, okay? ROS run teleop twist keyboard, teleop twist keyboard.py. So I'm going to copy directly this command here from the notebook and paste it here to the web shell. And this is going to allow me from the keyboard to move the robot around. So let me do this. Let me move a little bit backwards. There we go. Let's see if I can already see here from RVs. All right, so there we have the light, as you can see. Okay, now I can see this light, which right now is in the orange mode. So if I run my service again here, let's see if the light changes. Okay, so let me run my service one more time, and we should see this traffic light change to red, as you can see right here. Okay, and if I run it again, it's going to change to green. Okay, so as you can see here, using the camera, directly the camera of the car, we can see how the traffic lights are changing by using this traffic lights service. Okay, this is one interesting feature that you can use in this simulation. So yeah, so far so good. Have you been able to change the traffic lights and visualize them in RVs? Let me know here in the chat. Any issues? Something that you didn't understand? Because I know that sometimes I am doing things very fast, so some of you might get lost. Okay. Chuaib says that no issues. Great. Okay, so let's keep going forward. All right, then let's keep seeing other things. So we are going to review now what does this car provide in terms of sensoring. So basically, this car provides a laser. Okay, it provides an RGB camera, as we have seen right here. It provides an IMU. And it provides a GPS, okay? So all these sensors are going to allow us to create many applications, and they are going to allow this car to autonomously navigate, Okay, among other things, of course. It's going to be able to perform visual-based object detection, etc., etc. But let's have a quick look at all the sensors so that we get familiar with them. Then we are going to start by visualizing the laser, the camera, and the odometry in RVs. Okay, so we are here already in RVs. So let's start by visualizing the sensor. As you can see, we are already visualizing the sensor here. The sensor is the one that is providing these red lines here. We can increase it a little bit if you want. Let me find here the laser display, which is, let me minimize this. Here we have it, laser scan. It's this laser scan display, okay? I can make this, the size of the readings a little bit bigger if you want, so that we can visualize it better. You can tune this by modifying the size parameter inside the laser scan display. So right now it's at 0.03. So if I increase it to, for instance, 0.1, you are going to see that the readings are showing are much bigger now. Okay, so they are easier to see. Then all these red lines that we are seeing here are the detections from the laser. Yeah. So this laser, for instance, it's going to allow us to perform 2D navigation. Yeah, laser-based navigation. Also, we have the camera, which we are already visualizing here, and we have used it in the previous demo in order to visualize the traffic lights changing. Okay, so we already know how to visualize this. Then yeah, just to make this clear, so these laser readings, these red lines that the laser is providing to me, they are taken from the laser topic, which is this one, Hokuyo front laser / scan. Yeah. So if I do a ROS topic list here, I'm going to see among all these topics, I'm going to be able to find the laser topic, which is named Hokuyo. So it should be somewhere around. Let me see if I can find it. Here we have it. Okay, so this is the topic where the laser is publishing all its readings. Okay, and then we are using this topic in RVs in order to visualize it in a more graphical way. Why? Because if we try to read directly from this topic, for instance with a ROS topic echo, okay, we are going to get the information also, but as you can see, this is not very intuitive, okay? It's hard to interpret all these numbers. It's not trivial, yeah, to know what all this data means, okay? Then it's much more easier to just visualize it in this way, and then this makes much more sense because we can understand that all these lines here represents all the walls, buildings, and obstacles that the laser is detecting. Yeah? Sorry. All right. So what else? Yeah, so the RGB camera information, the camera that we are using here, it's getting the data from this topic, UI RGB camera image raw. Okay, this is the topic where we are publishing the RGB camera data, as you can see also here in the notebook. Again, we can also read the information directly from the topic of the camera. So we could do this and read the data directly from the topic. But as you're going to see, also this data, it's not easy to interpret at all. Yeah. So it's much better to just use RVs, and then with RVs we are able to convert all this information from the topic into a image, which makes much more sense. Yeah. So this way we can also visualize what the robot is seeing. Okay. Yeah, so also the odometry, which is published indirectly using the TFs. So we can also visualize the odometry here. Probably we have it. Let me get closer here to the robot. Another thing that we can do in order to visualize better all these frames that you can see are around here. So you can see here that down here we have some frames and so on. So if we want to visualize this better, one thing we can do is to make the robot model a little bit transparent. Okay, this is a trick that you can do by modifying here in the robot model display. If you open this robot model display, you can tune this alpha value here. Okay. And for instance, if you change this alpha value from 1 to 0.5, this is going to make the car a little bit transparent. Let me make it a little bit more. Like this. See? And now I can better visualize the frames that I am getting represented here. So here I have the base footprint, which is the frame that represents the base of the robot, and here I have the odometry frame. Okay? So for instance, if I move the robot a little bit here to the front, let me move it now to the front again. As you can see from here, this is getting closer to the odom frame. So basically, this odom frame is a fixed frame which is going to be static in the center of the world, of this world, okay? And then, as I move the robot around the city, this base footprint is going to get far away. It's going to get more far away from this odom, yeah? So for instance, if I move backwards now, I'm going to be separating from the odom frame, which is static there in the center, as you can see, of the world, okay? All right, so let me stop my car here. All right, then let's keep going. So far, so good, yeah? Let me have a quick look at the chat. So far, so good. Are you being able to follow everything? Are you practicing with me? So I don't want you to be just there watching the video and seeing what I am doing, but I want you to be practicing, okay? So all these things that I am doing, please do them yourself also there. That's why I have shared the licenses with you, so that you can access the course also and practice with me, okay? Ryan says that the traffic light visualization is not working, okay? So Ryan, I have explained previously, I don't know if you have missed it, or maybe this is a different issue, but if you change the traffic light and you visualize it here directly through the simulation, you are not going to see the changes, okay? So let me show it to you here. I'm going to call the traffic light services here, which is supposed to change the traffic lights. But as you can see here in the simulation, we are not able to see anything, okay? In order to visualize this traffic light changing, we need to visualize it through the robot camera, okay? Here. Using the robot camera here from RVs, I can run the service and then I'm going to see this light changing. As you can see, it changes to red now. If I run it again, it's going to change to green. There it goes. Okay? Yeah? Masiesh says, I am practicing too. I had problems with lack of camera in RVs. Now it's working properly. Okay, let me explain this also because it might be a little bit confusing, okay? So here we have the image display, okay? And by default, as you can see, we have different options here for visualizing. Then probably you are in, we have this traffic light detection, traffic signal detection, and lane detection image, okay? Skip all of these ones and go to the raw image, which is the last one, okay? Raw image. This is the one that is going to show you the car camera, okay? And also make sure that here in the RVs options, you have this raw image checked, okay? If you have it unchecked like this, it's not going to show anything, okay? So you have to make sure that the raw image option here in the displays, you have it checked. Okay? Like this. I have just checked it now. I can see raw image in RVs. Yeah. It's this one, Ryan. You have to be in this one, raw image. Actually, you can probably be on the other ones. No, this is another one, traffic light detection. No, these topics are for detection, so just ignore them, okay? So it's this one the one that you should go for here, raw image, okay? This one. You are going to be able to see the traffic light changing in this one, Ryan. Got it, thank you. I just missed that you were visualizing it in raw image. Okay, great, Ryan. Yeah. Okay, perfect. So let's keep moving then. Let's keep advancing. Okay, so also this car, it provides IMU and GPS data, okay? The IMU and GPS, usually we are going to visualize it not in RVs, but more, we're going to go for the raw data, usually, okay? So the IMU basically publishes the accelerations and orientations suffered by the car, okay? So, for instance, it can be used to know when the car is hitting the brakes too hard. So it has a very hard deacceleration. It can be used. It can also detect when the car is crashing with something, etc. Okay, this is the IMU, and we can access this IMU data in the IMU data topic. So ROS topic echo IMU data. Okay, we can access to this topic. To the data of this topic like this, okay? As you can see here, we have information about the linear acceleration, covariances, also the orientation, okay? And then we have also the GPS data, which we can access through the GPS fix topic, okay? So ROS topic echo GPS echo GPS fix. Okay, so here we can get the GPS coordinates of the robot right now. Yeah, we can see here the latitude, longitude, and altitude. Okay, as you can see in this case, the latitude and longitude are these ones. Yeah, which if you introduce these coordinates in a GPS, it's going to give you the following area, which is it's some random place here around Barcelona. Okay, so it's not a real position, of course, but just for curiosity, you can enter these coordinates in a GPS, and you are going to see where this imaginary city is supposed to be on Earth, on the Earth. Yeah, so to where these coordinates correspond in the Earth. And also we have, through the GPS, we can get velocity data. And we can access this data through the GPS fixed velocity topic. For instance, ROS topic echo GPS fixed velocity. Okay, so I can get also here the velocity vector. All right, you can see all the topics here in order to get the data from the different topics. So yeah, so with this information and knowing the basic sensors that this RV car provides, we are going to create a couple of basic programs to interact with our RV car. Okay. So the first program that we are going to create is a program that is going to calculate the distance, the current distance of the car to a desired distance that we can introduce in a GPS. Okay? So let's create this program very quickly. So for this, we are going to be following this example 1.1. So basically, I'm going to be copying the commands from here. So let's start by going here to our Catkin workspace SRC and running this command here. I'm directly copying the commands here from the notebook and pasting them to the shell, okay? So with this command, I have created a new empty package, this package named my RB car package. And then here we are going to create this GPS distance vector publisher.py script. So I'm going to create a new folder here named scripts. Let me create it right here. New folder, scripts, and inside this folder I'm going to create this new Python program, which I'm going to name GPS distance vector publisher.py. Okay, and then inside this Python script, I'm going to paste this code here. I'm going to select the code here directly from the notebook, select the whole code, copy it and paste it here to my program. Okay? So you should end up having the program here inside the package that you have just created. All right? Yeah, so far so good. Have you been able to create the package and the script? Let me see. What was the N1 argument for the ROS topic echo? Yeah, exactly, Ryan. So you have answered it yourself. It means to just show one message. Jared is asking how to launch the graphical tools. Okay, Jared, to launch the graphical tools, you have to click on this icon here, which looks like a computer screen, computer monitor. You have to click on this icon here, yeah? And this is going to open the graphical tools window. Okay. All right, so let's have a very quick look at this script. I'm not going to review it in depth, but just have a quick look to try to understand what it's supposed to do. So as you can see here, we are creating a new class, which we are naming GPS vector publisher. And then there are two arguments for initializing this class, which is the desired GPS location topic, which we are setting to this by default, and the GPS error, which is set to 3 meters, yeah, because this value is set in kilometers. So the GPS error is set to 3 meters, okay? Then we are initializing our class. We are setting the name of the topic where we are going to get the GPS data. What else? We are defining one subscriber here for the GPS topic. So we are subscribing to this data in order to get all the time the position of our car from this GPS fixed topic. And we are creating also another subscriber, which is going to subscribe to this desired GPS location. Yeah, it's going to be subscribed to this GPS desired location topic in order to get the desired location that we want to go to. Okay? Then we have here a function check GPS ready, which basically it's checking that the GPS fixed topic is up and running. We have here a GPS callback function also, which basically what we are doing here is to calculate the distance from the current GPS position to the desired GPS location. Okay? Also, we have here another function which is going to allow us to set the desired GPS location. Okay? So we are going to be able to set the desired GPS location by publishing into this topic here. Okay? And then here we have a distance function, which basically it's going to calculate the distance from the current GPS location to the desired GPS location, and it's going to use the great circle distance approach for doing so, which is it's a method to calculate the shortest distance in a sphere. You can Google it if you want in order to learn more about this. I'm not going to go over that, but basically you can review more in depth all this code if you want. But basically here what we are going to do is that we are going to set a desired location. Let me make this bigger. So, sorry. I need to rotate a little bit. So this program is going to allow us to set a desired GPS location, which for this example we are going to set this point here. And then our program basically is going to be calculating all the time which is the distance from our current GPS location to the desired GPS location, okay? And then we can drive the robot closer to the desired point, and we should see our program indicate that the distance is getting lower and lower each time until we reach our destination, which is this point with an error of 3 meters, okay? So let's try this and see how it works. Let's have a look to it in action. So basically, one thing we are going to need to do here is to give execution permissions to our script. As you can see, we can do this with these commands here. Chmod plus x GPS distance vector publisher pi. Okay, this command allows us to provide execution permissions to our Python script. And then we are going to just go back to our workspace and compile. Like this, cat can make. Actually, there's nothing to compile because it's just a Python script. But well, anyways, we can compile the workspace. And then now we are ready to run our program, okay? So let's run it. ROS run my rbcar package GPS distance vector publisher. So let's run our Python script, and then we are going to start receiving this error message, which says, not there yet, desired distance, and this number, okay? So now basically it's getting one default desired location, and then it's telling me that the robot is not there yet. And this distance is remaining in order to get to the desired location, okay? So what we are going to do now is that we are going to publish the desired location like this, yeah? We are going to publish into this topic GPS desired location, which is the topic that we have set in our program. So we are going to publish into this topic a desired location, which is going to be this one, this latitude and this longitude, okay? These values correspond to this purple point here shown in this image, okay? So we are going to copy this command here and run it in a different shell. This one, for instance. There we go, okay? So now we can see that the distance has been updated, okay? Updated desired position, as you can see, we have updated the latitude and longitude with these values here, and now it's telling us that we are not yet in the desired point, of course. So what we are going to do now is that we are going to start driving manually using the keyboard teleoperation program. We are going to start driving our car towards the desired GPS location, which is here in this corner. So let me start moving here the car towards that point. Yes, and as I get closer to the point, you should see how the distance is decreasing here, as you can see. Yeah? As I get closer to the desired location, I can see here how the distance keeps getting lower and lower, okay? So let's keep going. Let me increase a little bit the speed of my car so that it doesn't take so much time to get there. Okay, I'm going to start to rotate. Okay, having some troubles here rotating. Okay, let me stop. Okay, I'm going to crash my own car, really? I need to get better on driving, honestly. Okay. So let's... okay, let's go there. Okay, there we go. Come on, come on, come on. Yeah, I'm not very used to, as you can see, to work with this car. So it's being a little bit hard for me to turn it. Okay. But I'm going to achieve it eventually. Okay, yeah. Yeah, I'm almost there. Let's maneuver a little bit here. Okay. Okay, there we go. Okay, I'm in the path. All right, so now I'm getting really close, as you can see. So very soon I'm going to reach my desired location. I need to turn a little bit still. Okay, there we go. Yeah, so the desired point is here. As you can see from the image, is around here. So, almost there. Let's see. Okay, so I have reached, as you can see, I have reached the desired destination, okay? So this program is a kind of GPS, very basic program, but it's interesting because we can interact with different topics like the GPS, we can control the robot, etc. So, so yeah, this is, let me see here in the chat if you have said something here. Okay, so Masiej is getting success. So you have achieved to complete the exercise, Masiej. Very well, congratulations. The others, have you been able to reach the destination? So you are going to see that you have successfully reached the destination, as Masiej says, because you are going to start getting the success message. Worked fine here, says Chowipe. Okay, Ryan, have you been able to achieve it? Having a hard time driving. Controls are extremely delayed. Yeah, the problem, especially with driving, it's hard to control it using the keyboard, especially. It's not so intuitive. It's much easier to drive it using a program, in fact. Okay, so in the next exercise, we have, for the next exercise, actually we are not going to have time to do it, but for the next, well, actually I can run the program and show it to you, and then maybe we can later you can later review it by your own. So let me try it like this. It's much easier to control it, at least in my opinion. In my opinion, it's easier to control it and drive it using a Python script than using the keyboard. Using the keyboard, it's a little bit complicated sometimes to drive it around. So, for instance, the next one, I'm going to just create the program, and then you can review it by your own later. So let me create this simple obstacle avoidance. Simple obstacle avoidance script, which is this one. Here, let me copy it here from the notebook. This is the last exercise, actually. But it's a very, very obstacle avoidance algorithm, which basically, well, let me give it execution permissions. There we go. So it's a super simple. You can review it more in depth now, but basically it's a super simple object detection algorithm, which basically it's checking if there are obstacles in the center, in the right, or in the left of the robot. It's doing so using the laser readings. Okay, using the laser scan, it's checking if there are obstacles near the robot. So, for instance, if there is no obstacle in the center of the laser span, so in front of the robot, then it's going to keep moving forwards. If it detects an obstacle either in the center, in the right, or in the left side of the laser, then it's going to stop. If it doesn't detect an obstacle in the center, then it's going to keep moving forward. If it detects an obstacle in the right, then it's going to turn to the right, and if it detects an obstacle in the left, then it's going to turn to a left. Okay, so it's very basic. Let me run it and see how it performs here. Okay, so it starts, as you can see, with the robot moving forward, and now as soon as it detects this wall, it should start turning here to the right. As you can see here, it is detecting this obstacle in front, and then it's starting to turn to the right. So as you can see here, the driving of the car is much more fluent, okay? You can perform much more fluent turns and so on. So, so yeah, basically, worked success, says Ryan. Okay, great, congratulations. All right, so yeah, guys, I'm going to leave it here. I hope that you have enjoyed this live class. As I have been saying during this class, so now the open class is going to end, but you are going to have this license for 24 hours, okay? Well, 23 hours now. But the license that you have is going to last for 23 hours. So you can use it if you want to keep advancing through this course, keep up advancing through the next units, or you can change to a different course if you want to, check other courses from the academy. That's totally up to you, okay? But you are going to have this license for 23 hours. So yeah, and also for the ones who are going to watch this video on YouTube, remember that I'm going to leave the link to get your license in the description of the video, okay? So that you also can get your license and practice a little bit with it. So so yeah, basically that's it. How to complete this unit, just to see. Oh, Maciej, probably if you move to the next unit, it's going to complete it probably. Okay, don't worry about that. Otherwise, it's done using a time calculation. So it's going to complete it at one time. So don't worry about that. Okay, so let me switch here to my screen to close this. So yeah, thank you very much. I hope that you have enjoyed this class, and I hope that you have gotten this idea of how simple it is to set up a ROS online class or course with many students in just a few steps. Super easy to set up a online class of ROS like this. So yeah, thank you very much. I'm going to see you next Tuesday with the next live class, and as always, until then, take care and keep pushing your ROS learning. Bye bye.
The Robotics Development Masterclass is a bootcamp designed to help master robotics development from zero to advanced and get you fully prepared to work in any robotics company. From the basics of programming Python and C++ to advanced robotics programming techniques like ROS, robot perception, and autonomous robot navigation. Build a robot simulation from zero, make a robotic arm, perform pick-and-place tasks, develop a web app that interacts with a robot, and more. This program will equip you with 99% of the skills required for any robotics development job. Every day, you will learn each concept by practicing with simulated and real robots. Combine our online IDE with remote real robot labs that will drop you into real-world scenarios and make you learn by doing it in real RobDev environments. You'll have a dedicated mentor to guide your progress, answer all your questions, and ensure your success. The Robotics Development Masterclass will also provide you with a 1-month internship in a leading robotics company. You'll learn from industry practitioners and enhance your knowledge. Enroll now to kickstart your robotics career with the construct.